Well, welcome to this third part of the tutorial, in which we'll turn our brick wall into a rigid body object. I made one small change to the scene file, which is to add a transform at the end here, which raises the whole wall up by half a brick, because it was sticking down slightly below the ground. Now, we're going to use what's called a rigid body glue object for this wall. Rigid body glue object is made up of lots of subsidiary objects, such as the bricks in the wall, which are glued together. And they stay glued together until they're hit by something sufficiently strong that they break apart. And that, of course, is exactly what we want with our wall. So in order to create a rigid body glue object, each of the separate sets of primitives, the separate objects in here, the separate bricks, has to be in a different primitive group. Now, you can in fact achieve that using the copy sops, but a more general method is to add a connectivity sop. And what this does is create an attribute. By default it's called class, and I'm going to make it a primitive attribute which sets the class to a value for groups of connected primitives. So each of these bricks will have a class value that's the same and different from all the other bricks. And we can then use a partition sop to create groups based on the value of this attribute class. So this will create groups based on a rule, and the rule is simply a bit of text. So I'll call it group underscore, and then the variable that's going to vary across each group. So let's have a look at that in the details view. So first of all, at the primitive level, we should have class attribute, and as we can see, primitives 0 to 5 are all in the same brick, and 6 to 11 are in a different brick, and so on. And if we have a look here by middle clicking on our partition sop, we can see that we have 110 primitive groups, which is the same number of groups as there are bricks. So let's set up a ground plane, which we can just do by clicking on the ground plane tool in the shelf. Ground plane is just an infinite plane for the bricks to collide against. And then let's select our bricks and make them into an RBD glue object. There we are. Play. It's busy calculating the SDF, the volumetric representation of the brick wall. And then it should eventually run reasonably quickly, because we don't actually have anything happening yet. And in fact, I'm going to speed that up by going into our auto.network, which has just been created for us. Let's hit L to lay out these nodes. This is our wall, and we can see that there is a collisions tab. And this, amongst other things, allows us to define how the bricks are represented for collisions. At the moment we're constructing a representation of them using volumes. I'm going to use implicit boxes because that's essentially what they are. So if we do that, hopefully our simulation should run more quickly, and indeed it does. Now, in fact, one of the important things to get right before you start simulating is the size of your objects. And the units in Houdini are not just arbitrary, but they're real word units, and indeed if you look at the help page for about Houdini Dynamics, at the bottom it tells you which units Houdini uses. Mass is in kilograms, distance is in meters, density kilograms per meter cube, and so on. So we need to make sure our wall is the right height. we've got 10 rows of bricks here. I'm guessing that the average brick is about 20 centimeters tall. How tall is our wall at the moment? Well, we need to dive inside and have a look at our last node, and one of the things it tells you if we middle click on it is the dimensions, and that is clearly the height, which is about 5. So I need to insert transform node because 10 rows of bricks at 20 centimeters high should be about 2 units high overall, because 1 unit is a meter. So I need to change this down to 0.5. And notice we do that before the DOP import, which is the thing that draws the wall into the simulation. Okay. Now in the auto.network, I need to set up the density of our wall, and a quick look on the internet will tell you that your average brick has a density of 1,800 kilograms per cubic meter. What I need to do is create an object which is going to collide into the wall. I'm going to use a sphere, so let's just dump a sphere into the scene. I'm going to reduce its radius down to something like 0.4, and I'm going to make it a polygon mesh. And then at the scene level, let's transform it and move it so that it is pretty much in the middle of the wall. Now to create a rigid body object from this, all I need to do is, with it selected, hit the RBD object button, like so. And that should have added it to our scene, and it has, here in the auto.network. I'm going to make a couple of changes. One is to change its collision mode into implicit sphere to speed things up. Secondly, I'm going to change its density to 7,800, which is roughly the density of iron. And finally, I'm going to give it an initial velocity, which we'll put in here. Initial x velocity of 20 should move it pretty rapidly towards and into the wall. So let's see how that works. Well, we can see that the wall as a whole has fallen over, and that's not necessarily what we want. There are two reasons for this, in fact, one of which is that we haven't glued our wall to the ground plane, and the second of which is that the default glue strength, here we look at our wall, we can see the internal glue strength of 5,000, is far too high. The impact created by the ball is not sufficient to break the bricks apart. As a result, they're falling as a single unit. We can have a look and see at the impact that the sphere is having, and the reason that we can do that is because by default on the rigid body solver here, the add impact data option is enabled, and that means that for those bricks which have suffered an impact, the data will be available here in the details view. So we need to know the name of these bricks here which have actually moved. Let's try and find the name of that one there. And we can find it by hitting the D key to bring up the display options and enabling object names. And if we go into wireframe view and zoom in, that brick there is group 74. Let's turn the names off. So we should find, if we go into a details view and have a look, and here we've got a list of all our objects. If we have a look at group 74, we should find that there's some impacts data, and there it is. And if we expand it and have a look at the Impacts tab. This is a list of all of the impacts. Let's see what we've got here. We've got impacts that are 2, 3, 4, 1, 2, 3, and a lot of impacts that are 0, or near 0. So those are pretty low numbers. If you compare that to our glue, 5,000, you're going to need a lot of impacts for the glue to break apart. So we need a much smaller value. Let's try 10. And I'm going to rewind my simulation. And let's have another look.